Okay, question 5. These are great questions. I think the minute you get anything like this, it's very prescriptive, and you can just kind of go through the same routine every single time. And also, if you scroll up to your equations, you're given a bit of a help as well. Just highlight that. You've actually got your formula. Okay, so whenever you see anything to do with mean or standard deviation, you've got the formula. We should be able to get something here. Okay, let's just go back there. So the midday temperatures in Grandford were recorded over a 9-day period. I'll just highlight Grandford. Okay, and we're looking at midday temperatures. Right. Over a 9-day period, so it means we're going to have 9 bits of data. Okay, and these are the temperatures. Calculate the median and the semi-interquartile range of the temps. Okay, well, the first thing you want to do is write them in order from lowest to highest. Okay, so 3 and 3. I've got a 4 and a 4. And just take your time with this, because you make a mistake here, it just filters all the way through, and it's very frustrating later on. 5 and 6. Oh, and then 7, 9, and 10. Okay, so that's me got 1, 2, 3, 4, 5, 6, 9 bits of data. And I'll just double check just to make sure. So I've got 3 and 3, 3 and a 3. I've got a 4 and a 4. I've got a 5 and a 6. I've got a 7 and a 9 and a 10. Okay, so I'm quite happy I've got that right. The median. So the median is just a number in the middle. Okay, so if you're not great at finding that, well, if it's an odd number like this, it's dead easy, because it's just a number actually in the middle. Okay, so again, feel free to pause the video if you know what the answers are or work through it. But the number in the middle here is 5, because I've got 4 numbers on this side. Okay, and I've got 4 numbers on this side, so that's the one in the middle. Okay, if you're not sure how to find it, just kind of rub out or cross out numbers on both sides. Okay, one from each side until you're just left with one in the middle. Okay, but if it's an odd number, it's nice and straightforward. It's just the one in the middle. Okay, brilliant. So right away, that's what's got a mark. Semi-interquartile range. So we're just looking now effectively for the median on the top and bottom sets of data. Okay, so I've got a different pen out. So the bottom set of data is down here. So what is the middle number of this bottom set? Okay, so what's the bottom set there? What's the middle of that? Yep, it's going to be 3.5. Okay, and then here's our top set of data. What is the middle of the top set of data? It's just going to be 8. Okay, nice and easy. Okay, and to work out the semi-interquartile range, we just do 8 take away 3.5 divided by 2. So that's 4.5 divided by 2, which is 2.25. Okay. Obviously, you would get a mark for stating the median. Okay. Now, the way I've laid it out, please actually write median equals 5, etc. This is just kind of rough working on it. You should summarise it at the bottom, to say. Your semi-interquartiles are 3.5 and 8. So that's actually just, they're a half mark each. So that's actually just 1 mark for them. And then you got a mark for that as well. Okay, so it's kind of like a half mark and a half mark. Okay, although you never get half marks. Okay, so quite straightforward so far, I think. Yeah, we're not actually being asked to work out standard deviation, which is a shame, but they're just as straightforward, really. Okay, so yeah, you found your Q3, your Q1, your median, and your range. Brilliant. So now it's asking to make comments. This is where people seem to fall down quite a lot, which is a shame, because it is, again, very straightforward. So we know it's to do with temperatures, and we've got Grandford. Right, now we've got temperatures in Endrick. Right? Now they've said that their mean was 8, and their range was 1.5. Doesn't matter if it's the semi-interquartile range or the full range. Okay, it's still the same idea. The smaller the range, the more consistent the results. And I always think of like a dartboard. I always think if you're playing darts or something, and you get everything right in the middle, you've got a very small range, you're very consistent. But if you're all over the shop, you're not very consistent, and that's kind of the same with the range, okay? The word spread's used a lot as well. Okay, so a big range seems a big spread of results. Okay. So 2 valid comments. We're going to be commenting on the median temperature, okay? And we're going to be commenting on the range, okay? Which we're going to say is consistency. So for the median up here was 5, and the median here is 8. So always start off with on average. The median, excuse the handwriting, temp, and then pick a place, pick the first one, like Grandford. Median temperature in Grandford was lower, okay? Now, lower means you understand what's going on, because 5 is lower than 8. But you need to be very careful to make sure you use the phrase median temperature in Grandford. Okay, we need to really tie into the question. Okay, so let's look at range, which we're going to say is consistency. So I'll just say, I'll just rub that out for space. I don't actually need to have this either. Okay, just this bit here. So our second statement, we're going to say on average. The median, or maybe just the, not the median, sorry. Just say the temps in Grandford. Now, the range here is 2.25, and the range here is 1.5, so we've got a bigger range in Grandford. Okay, so on average, the temps in Grandford were less consistent. Okay, so the median in Grandford was lower. 5 was less than 8. 2.25 is a higher spread, so it gives it a higher spread or a lower consistency. So less consistent or a higher spread. Okay, but it's very, very important that you link it in with the fact we're talking about temperatures and we're talking about these places. Okay, good stuff. So yeah, a mark for each of those. 1 mark for each statement. Okay. Now this is a really good question. Oh, pardon me. Equations of a straight line. So, fuel consumption of a group of cars is recorded. It's on the scatter graph below. And this is a relationship. They've drawn a line of best fit. And we've got to find what that equation of the line is. Okay, so what is the equation of a line? Well, in its most basic terms, y is equal to mx plus c. Let's not worry about f and e just now. That is the equation of a line. Okay, that's our x-axis. That's our y-axis. Okay. So, what is m and what is c? Well, m is the gradient of the line. So, working out the gradient, let's go up here. That's not very straight, but if we've got a line that's going in this direction, like this, that'd be a positive gradient. If we've got a line going in this direction, that'd be a negative gradient. So we know we've got a negative gradient from looking at this. Okay. Again, I always think of my kind of reference line. My kind of y is equal to x. So this is kind of like a gradient of 1. Okay, so if you've got 1 here, you're going to have 1 over there. If you have 2 here, you're going to have 2 up here. Okay, that's a gradient of 1. Okay. C is the interceptor where it crosses the y-axis. We actually can't see where that is, but it's probably about 18-ish, is that kind of number, looking at that. Okay. But we can't work that out just yet. So this is our equation of the line, and we need to try and solve it. So we've got 2 unknowns, and the only one we can really work out just now is m, because we don't know c because we can't see where it crosses the line, but we know m because we can work out m from the equation y2 minus y1 divided by x2 minus x1. Okay, so we just need to find 2 points on the line. So there's a point there, and there's a point there. Very important not to use points not on the line. Okay, and then we just substitute in. So let's call this point number 1. We'll call this point number 2. So point number 2. What's our y value for point number 2? It's 8. And what's the x value? 3.5. So there's 8, and there's 3.5. And from that we're going to take away point 1. Y is 14, and x is 1.5. 14 and 1.5. Okay, so that's divided by 2. 8 minus 14 is 6, minus 6. So that's going to be minus 3. So there's our gradient. Now to work out C, we just substitute a point back in here with our m. Okay, so let's take point 2, be nice and easy. Okay, so point 2 is 8 and 3.5. So we've got y is equal to 8, m is equal to minus 3, and that's times the x, which is 3.5. And then we're going to add c. Okay, so minus 3 times 3.5, minus 9, minus 10.5, plus c. So minus 10.5 plus what is going to give us 8. We'll just move that over to that side, won't we? We'll just add that on to the opposite, don't we? So to get rid of this, we need to move over here by adding it on. So 8 plus 10.5 is going to give us 18.5. So it's close to a guess of 18. Okay, so that's our C. Okay, so nice and straightforward. All we did was we used the equation of a straight line. We worked out M, which is this section in here, and then we substituted back in one of the points to work out C. Okay, so in terms of marks for that, you would get a mark for your gradient. Yeah, you would get a mark for working out C. The very last part, which I've not done, is putting it into terms that's in the question. Okay, so now we want to go back and say, well, y is actually equal to f. Yeah, we know that m is minus 3, x is e, and we're going to plus 18.5, and that's your final mark.